Hello, welcome everyone. Today we are doing physics, and in physics we are continuing with the waves. So in waves we have completed, here you can see till we have seen what is the ultrasound imaging, how the bats use the ultrasound to locate a particular prey, and similar techniques are used in a different technologies in different fields. Now we will study, there is a one term that is called echo, and we'll do some questions, like few one or two questions related to one that we have discussed so far, and then we'll move on to the light waves. So echo is nothing but it's a reflection of the wave, of the sound wave more specifically. So simple, the sound that you will hear after the reflection, suppose you say something, when it gets reflect back from a particular surface, again you will hear that. So that reflected sound is basically your echo. Now let me do some questions on whatever the formula we have done so far. See this question, it says a source has sent a sound wave with a speed of 340 meters per second. The wave took 12 minutes to travel from source to targeted place. Suppose this is source and this is the target, and then this is receiver, which is just side by side. So the wave took 12 minutes to move from source to target and back from target to receiver. This is the total time taken is 12 minutes. Now you have to calculate the distance between source and target, only this and this. So if I say this be the time taken, t be the time taken, so same time will be taken, because they are just, it's not like it's making any triangle or something or hypotenuse. It's simple that the wave will travel back like this ultimately. So it will travel the same distance that or same time. So t will also be the time for returning of the wave. So if total is 12, that means if we are calculating the distance between source and target, so time will be 6 minutes, because 12 minutes is the total time taken from source to target and back to the receiver. But only from source to target will be half, that means 6 minutes will be taken. So speed is equals to distance over time. Speed is 340 meters per second. Distance is we have to calculate, and time taken is 6 minutes. But this is in meters per second, which means we have to convert 6 minutes into seconds. So multiplying it with 60. So distance will be 340 into 360, which is 122,400 meters, or we can say in terms of kilometers it would be 122.4 kilometers. So this is how you can calculate the speed. The speed of the wave can be calculated with a different method as well, with a different formula, which is wave speed is equals to wavelength into frequency. So the next question is related with that. This question is saying a wave of wavelength 12 meter has a time period of 0.1 seconds. Calculate the speed of this wave. Here the time period is given. Clearly the speed of a wave you can calculate by two ways, distance over time, and here neither the distance nor the time period is mentioned, but not the time is mentioned, so we can't use that. So we have to use wavelength into frequency, which is actually kind of similar thing, which is also derived from the same speed over time, but it's wavelength into frequency. So I always ask you to go in a reverse order. If they are asking to calculate the speed of the wave, so go in a reverse order. So that means first will write the speed of the wave, formula to calculate speed of wave, which is frequency into wavelength. Wavelength we know, which is 12, but we don't know the frequency, but we know that frequency is 1 over time period. Time period is 0.1 second, so 1 over 0.1, that is frequency is going to be 10 hertz. Multiplied by 10, ultimately we'll get speed as 120 meters per second. So this was all about the basics of the waves and the sound waves. Now let me move on to the seismic waves. So let me see this one. So what are seismic waves? Seismic waves are basically the vibration generated by the earthquake, or you can say explosion, or any similar that level of energetic source that produces the seismic waves. Basically, there are four types of seismic waves, but the two types are the main types that are in your syllabus and that we will be studying. So let me write down the definition of the seismic waves. So simple. How you can define the seismic waves? They are basically the shock waves that are produced by earthquake, any kind of explosion. It can be a volcanic eruption as well, and any source which is similarly energetic. These waves actually propagate within the earth or along its surface. As I described you, there are four main types of waves, seismic waves, but we will be studying the two main sources, which is P wave and S wave. Now, P waves are basically longitudinal waves, and their speed is comparatively faster than the other waves. P waves can travel through solids and liquids. They can travel through solid and liquid both. Whereas if I talk about the S waves, they are transverse in nature. P waves, as they are P, that means it stands for primary waves. So these are the waves that are produced first. When there is an earthquake, the first wave to be generated is the P wave, that is, it's called primary wave. After a few seconds of a time, there will be a next cycle, next vibration ripple, and that will be through S waves that are called secondary waves. So these secondary waves are transverse in nature. Long P waves are, we just saw, that longitudinal in nature, whereas S waves are transverse in nature. They are comparatively slower than the P waves. P waves are pretty faster, but as compared to the P waves, S waves are slower, and they can travel through solids only. Unlike the P waves that can travel through solid and liquid, S waves can travel through solid only. There, as I say, there are four types of waves, but mostly two waves are in our syllabus. But we can add the third one that we generally say is surface waves. So surface waves are also longitudinal waves like P waves, and they are the slowest among all. P waves are the fastest, S waves are a little slower, and surface waves are the slowest one. And they travel along the surfaces only, and that's why they got their name. The exam based answers for this question, S wave and P waves, so far what we understood that they propagate basically within the earth and along its surface, because they are produced by the tectonic plates, if because of the volcanic eruption. So these things are basically happening to the crust of the earth, and then they can pass through it. So as the name suggests, P waves, they are the primary waves, which suggests that they are the first one to be produced, though the secondary waves are produced just after the few seconds of the primary waves. Let me see the basic properties of P waves. P waves are longitudinal, whereas S waves are transverse in nature. P waves can pass through solids and liquid, whereas S waves can pass through only solids. Because P waves can pass through solids and liquid, they are passing through different region from different medium, and this results in refraction. That I mentioned that these waves refract as they pass through different layers. Why I have written that this is an important property? Because this refraction affects the reasons which waves can be detected, that in the wave is moving basically, and this gives us a very important information about the nature and size of the earth's various layers, because these waves can be detected when they pass through it, they can be refracted from them, and by studying these waves, you'll be able to know what is the basic structure and the size of the earth and of these different layers. So they give us a very important information about the earth. Whereas the S waves, if we talk about the frequency, the P waves are infrasound waves. They are a very low frequency sound waves, and we know infrasound are those sound waves that have the frequency lesser than 20 hertz. They are faster than S waves, and whereas the P waves are obviously slower than S waves are obviously slower than the P waves. Now for the S wave, it's important I have written that they can pass through only solids, unlike P waves. P waves can pass through solids and liquid, and they reflects and give us information about the size and shape of the different layers of the earth, whereas the S waves can pass through only solid. It means that they cannot pass through the center of the earth. Then you will be able to know that whether the particular center is a liquid or in a solid state, because if it would be in solid, then S waves can pass through it easily. But if S wave cannot pass through a certain region, then we'll be able to know that this is the a molten part, this is a liquid part. And as they cannot pass through the inner side, or like inner, that means not the most inner, I'm talking about the mental part, they cannot pass through it. This gave us an important information that this part is completely liquid. So what's happening is that these two waves together is giving us a very important information about the uh, quality of the earth layers, structure and size of the earth layers. So this was about the S waves, P waves, seismic waves. We have completed the sound waves as well, and the basics of the waves we have already completed. The next we are starting is electromagnetic waves, and that we will be doing in the next lecture. So I'm just ending this lecture right away. Even I have given you what you're supposed to write in the exams as well. You just need to revise, and we did one or two questions in this lecture as well. So go and try those questions. And I'm running GCSE batches, I'm running revision classes, and I'm running the doubt sessions as well, because the exams are quite closer. And what all you need to do is that revise, and if you have any doubt, even if you need just one lecture or two lectures, just email us at exactacademy@gmail.com. We will book the class and will coordinate accordingly. You can write down your subject as well. And for the new sessions for any subject from year 1 to year 13, you can contact us. Just email us at exactacademy@gmail.com. And these all notes and the worksheets on science and physics you can access on exactacademy.com. We will be posting on more subjects as well for the different boards as well. Thank you. Have a great day.